My name's Mark Clay. I'm an investigator. I work primarily out of the CMR building, one of the reasons I'm up here today. As all of you know, last November, we had an explosion of fire in the CMR building. Many of you probably heard about it the same way I did, at least initially. I was watching the 10 o'clock news when I heard about it. During the next hour or so, we hope to answer a lot of the questions. We're going to talk about what happened before, during, and after the CMR accident. Some similarities with that accident, some of the other major ones, and some of the lessons the laboratory has learned collectively from these accidents. Participating with all of us today are Johnny Harper, who led the accident investigation team, Ross Lemons, the Division Director for Material Science and Technology, Alex over at Gancarz with the CST Division Director, and of course Sig Hecker, the Director of the laboratory. Before we get started, I want to say something to you all. We all made mistakes together, and we're all going to find the answers together.
The reason that we're here is to learn from the CMR accident, and particularly as to what we could learn to make this a safer place to work. Look, last November 14th, that evening, my heart dropped when I got the phone call that we had an explosion in the CMR building. And my first thoughts turned to, my God, did anybody get hurt? As you well know, for the grace of God, nobody got hurt in that particular accident. The next morning, Jim Jackson and I went over to listen to kind of the quick take brief and analysis of the accident. And it became immediately obvious to us that, look, what happened here really runs right to the core of what this laboratory does. Pretty much every experimenter at this laboratory at one point or another has to go in and define the work and then think about the hazards that are there. So I thought, where were we when we really tried to analyze the hazards for this? What did we do to try to mitigate the hazards? Did we do the work safely? And then what are we going to learn from this? And my thoughts were, this isn't about the Department of Energy. It's not about bureaucracy. It's not about paperwork. It's about people getting hurt, and potentially about people getting killed. So what I want you to do is to hear and listen, to understand what that accident really meant, and then most importantly, to take the lessons back from that in how you do work.
The project that we were doing was called the Design Evaluation Program, Design Evaluation Project. We were doing the project in CMR. CMR is around 550,000 square feet, some 13 acres. It's one of our biggest facilities at the laboratory. And Wing 9 is that wing on the upper left up there where we were doing this experiment. And this was a joint project. CST division had people that were working on the project. And we were doing this jointly with people from Ross Lemons' division, Material Science and Technologies. In that project, we're taking nuclear devices apart and doing aging studies on the components. And we do those aging studies by heating the components and looking at some of the gases that are evolved from them. There were 4 ovens and there were 4 canisters. Here is a photograph looking into an oven. It's now a doorless oven. The oven itself is about 2 feet by 2 feet by 2 feet. So you get a sense of how big that canister is. Thick-walled canister, stainless steel. It's got a welded flange on it and a whole series of bolts holding it together. So the idea was that people disassembled the secondary of the nuclear weapon, put the parts in these canisters. The person that was doing this set the oven temperature to 250 degrees centigrade, put the canisters in, went home, was going to come back later that evening to see how things were going. Unfortunately, there was some confusion about which oven and which canister belonged to what. And in this particular material that was put in this oven, that was heated up to 250 degrees, starts to decompose at a much lower temperature, around 75 degrees. As it started to decompose, it built up gas pressure in the canister, probably up to somewhere in the order of 2,500 pounds per square inch. Popped the flange, popped the door off the oven, accelerated the top. The next slide shows the ensuing damage that we saw. Now this is a photograph where the experiment was being conducted in Wing 9, and on the left you see a series of gas cylinders, some twisted racks behind it. Those gas cylinders were supplying gas, which was part of the experiment, and those twisted racks behind are what's left of the experimental apparatus, that is the ovens, which contained one of the canisters. The next picture shows you that canister after the explosion. We got the wrong canister in the wrong oven.
Since late 1994, 4 other serious incidents have occurred at the laboratory, and in each of those, we weren't as fortunate in the CMR incident because in those incidents, somebody did get hurt. The first thing I want to talk about happened in July of 1996 at TA53. A graduate student employee was working alone on a project that required him to take some voltage measurements inside of this commercial microwave oven for a power supply in that oven. To take the measurements, the employee removed the cover of the oven, and with the oven energized, attached those 2 high voltage probes to the main tube, and then inadvertently, we presume, he attached the grounding wires for the probes also to the tube. The student employee apparently was shocked when he touched the high voltage, either directly or when he touched those adjustment boxes. He was unconscious. He had burns on his hands, on his back, and on his shoulder. He received surgery for a dislocated shoulder, and he was released from the hospital 3 days later. The next incident I want to talk about happened the day before Thanksgiving in 1995. A laboratory employee was seriously injured when the forklift he was driving rolled over into that grassy ditch at a building, outside a building at TA35. The employee was using the forklift to get those bottles. As he was coming around the corner, the left wheel slipped off the berm, and then the forklift rolled over into the ditch. The driver's neck was pinned under that overhead guard that you see there on the bottom of the picture. Later on, emergency personnel were able to free him, and they took him to LAMC. He was later taken to the St. Vincent's Hospital, where he received surgery for his injuries, and he was released from the hospital 17 days after the incident happened. Another one that happened in January of 1996, the JCI mason and a foreman were performing excavation work in a basement room at TA21. On the day of the incident, the 2 employees took turns using a shovel and a jackhammer to take dirt and tuff out of that hole right there. After using the shovel for a time, the mason handed the shovel to the other employee and took over with a jackhammer. A moment later, the foreman saw the mason start shaking violently, and he heard an explosion. The mason had hit an energized 13,200 volt underground power line with the jackhammer. You can see the burned areas actually on the jeans he wore underneath the coveralls there, the big burn spot. This employee is still not recovered from his injuries, and he requires 24-hour care as we speak right now. The next incident I want to talk about, the last of the 4, happened just before Christmas in 1994. A security employee was fatally wounded out there at the firing range on a force-on-force exercise on the truck route. The DOE required exercise was testing the effectiveness of some facility protective measures. In the exercise, there were 3 security employees acting as adversaries, and there was a team of security employees acting as responders. The test was supposed to be performed with blank ammunition using equipment that included the rifles and vests that you see in that picture right there. During the 3rd run-through of the test, one of the responders saw an adversary lying on the ground with his rifle ready. He was lying in that shaded area. The responder saw the adversary, and in keeping with the exercise, he opened fire, and another person in the area saw that the adversary was being hit by live rounds of ammunition. The wounded man was taken to LAMC, where he was pronounced dead a short time later. I've been investigating occurrences at the laboratory for about 4 years, and in that time we've had over 900 incidents that have required formal notification to DOE. Perhaps not surprisingly, there are a handful of the causes that are common to a great many of the incidents, including the CMR incident and the other 4 that I've just described. Keep in mind that these incidents involved good people. They were doing their job. They thought they were doing the right thing. They were trying to help. They thought everything was in place. One of the frequent common causes that we hear in a lot of these incidents and happen in these is the failure to ask and seriously consider and then find an answer to questions like this. What are the one or two major things that can really go wrong here, and what can we do to keep them from happening? Surprisingly enough, that basic question doesn't get asked as thoroughly as it should. Let me give you some examples. During any test exercise in a firing range, when people are going to be intentionally pointing guns at each other, what would be logically the one thing that we would want to take care of? Do we have bullets in the guns? For some reason in this incident, that didn't happen adequately, and look what happened. If we're going to be maneuvering a forklift on an elevated surface that is not much wider than the forklift, that's pretty tricky even for somebody with a lot of experience. On the day of the forklift incident, however, the driver, who was not qualified to do what he was doing, but he was really trying to help, he didn't stop to think about that before he got on there. Probably the worst thing that can happen during an excavation work, what can you imagine it is? The worst thing that can happen. Hit something live on the ground, whether it's a utility, especially maybe a high voltage line. This worst conceivable thing that could happen, it did happen. One of the greatest hazards associated with the work on the microwave oven was being exposed to energized high voltage connections when the oven was on and the cover to the microwave was off. There was really only one chemical compound in that accident at CMR that could really become hazardous under the right conditions. In this case, the right conditions would be, as Alex pointed out, heating the compound under pressure above its maximum prescribed temperature. You know, one of the reasons that these worst things were not prevented was that people involved in an incident were not exactly sure whose job it was to make sure that those worst case things were identified and taken care of. What those people didn't realize was that the hazard review process had not taken care of the reasonably possible worst case condition, and if they didn't stop and take it upon themselves to look at that worst case thing and take care of it before they started work, they were in serious danger. One of the common themes we hear about this is why these things don't happen, why we don't recognize these things, is time pressure. A deadline is approaching. A project is not achieving results in the time that's expected. Samples need to be measured and get taken out of here right away. A holiday or a weekend is looming, and people feel that they have to get the job done as quickly as possible. And these are go-getters. These are people that do get the work done. But for some reason, we miss these things when these time pressures come along. The firing range incident, the required exercise had to be completed before the end of the year, and the Christmas break was coming up. The forklift, you remember when that happened? The day before Thanksgiving. The people who normally operate the forklift weren't available, but they had to get the bottles going because they had to keep the experiment going over the break. And the excavation work in the basement was part of a large laboratory-wide project to rapidly come in compliance with environmental concerns. The project at CMR was being done with limited funds and limited resources to meet project deadlines. It seems that when time or money pressures are present, the employees are so focused on the job that they got to get done that these things get missed. And that's something we got to stress, is that we got to catch those things.
The CMR accident wasn't about ES&H division. It wasn't about ES&H professionals. It was about people doing work, scientists, technicians, and we had a problem.
This was a joint project, and when we received these canisters from Material Science and Technology Division, there was confusion about the information that went with the canisters. There was confusion on CST part about what that information was.
We tried to understand who was responsible for what. You can see there's various divisions, various groups, distributed services, deployed services. It was a very confusing organization. When you're dealing with a project and you're handing off things, there's a chance for confusion. It's at your interfaces where you have your accidents, whether they're within a team, within a group, across groups, or across divisions.
In order to make sure that we don't get into a dangerous situation where we think somebody else is taking care of it, somebody else has responsibility for that, we've tried to make it very clear that really we're going to try and operate with line responsibility. The person doing the work is the one who knows most about it. Therefore, they probably have the best understanding of what those hazards are. immediately up the line are their supervision, their line management, their group leaders. Those are the individuals who, once again, know more about that kind of work than most anybody else in the institution. They're in a better position to be able to judge whether or not reasonable controls have been put in place to address the hazards.
One of the things that I've learned about the responsibility here, somebody's got to be responsible and somebody's got to be accountable. And in this case, it's real clear how it goes. And the primary tenet of integrated safety management is line management is responsible for safety. It's a CST division employee who was doing this work. The accountability and the responsibility flows from that employee up to her group leader, up to me, up to Sig.
If we had done the hazard analysis appropriately, enlisted the help of the appropriate safety professionals, we wouldn't have had that accident.
It's sort of like you're driving down a road and you see what's in front of you, but you're not looking at the side roads. And what's actually going to hurt you or kill you is the vehicle that's coming from the side that can broadside you and really do that damage. And so in my mind, one of the most crucial things we have to begin to develop is the step in which we pause and do a systematic investigation and evaluation of the hazards, and we ask the what-if questions. What if this happens? What if that happens? Where I think we've often failed is that we don't do the kind of systematic, methodical evaluation of the other ways that an accident can happen. We're all pressed by many different factors, and so you can get distracted. And you have to sort of remind yourself every day, every time you walk into your lab or your office, what is it I'm doing? If there is something different, then you need to re-engage how you look at the hazards. If there's not, then you need to at least make sure that the control systems that you developed are actually in place and are working.
You know, after all, if somebody doesn't turn the switch, an accident doesn't happen. And so right then and there, when somebody turns the switch, you have to make sure that you've gone through the 5-step process. It's very simple. Sometimes the hazard analysis is very complicated, but we got lots of smart folks who can help to do that. But the fact that you have to go through and do the hazard analysis is absolutely key.
The recommendation that the group that put together the corrective actions made was that we develop and provide training in doing effective hazard analysis and evaluation for every individual that is engaged in a medium to high hazard operation. In addition, we went through and redid and reevaluated all of the procedures associated with those aspects of the project. The people in FSS have redeveloped the guidelines to ensure that security does not compromise safety.
We're making sure that our people are clearly understanding what their roles and responsibilities are, their responsibility particularly for going back and following the 5-step process of understanding what the work is, making sure that they have the hazards outlined, making sure that they have all the mitigation controls in place before they execute the work, and then going back and then analyzing how they did it. So we're really working with the employees to do that. And then the facility managers and CMR and I are going back and reviewing our processes for how do we do hazard analyses and how do we make sure that the facility has everything that it needs in place to provide that safe work environment.
From a broader laboratory perspective, what really occurs to me, you know, especially as I watch and see diagrams like Johnny's diagram, the wiring diagram, or you could call it a spaghetti diagram, you know, it tends to make things look very, very complicated. And in fact, this stuff isn't rocket science. First and foremost, and this is what the CMR accident really brings home to me, is the issue of work control. The second piece that we worry about from a laboratory standpoint is essentially the management safety system. We in management are responsible for the environment that we create in which our people turn the keys or push the buttons. And I think that's a key responsibility. And again, integrated safety management really has that piece. So it's not rocket science. It's very straightforward. It's very simple. And we've got to demonstrate that we have the discipline to do that because we don't want people to get hurt.
I guess getting down to a more of a personal level, does, what have all of you personally learned from these things?
People don't come to work wanting to mess up or get hurt. Everybody wants to do a good job. To me, I realize that quality assurance is more than just a check in a box. It's more than just a procedure.
Ross?
Oh, I guess many things. One of them is that simply we have to reduce the frequency with which these things happen to zero if possible. If we're not all committed and engaged in doing that, it's not going to happen. Another one, I guess, is that we need to have systems that really are effective and workable for the people who are going to use them.
Alex?
First of all, is that I'm responsible for safety. I don't pay somebody else to be responsible for safety. It's part of the work.
You know, the thing that struck me the most is I'd already told you that my heart sank, with the first sentence of the phone call, that we had an explosion in the CMR building. The second sentence really brought home what really safety is all about to me. The second sentence was, but there was nobody hurt. The sigh of relief that's there when you realize that somebody isn't hurt, didn't die, is one that really brings home that the most important reason we do safety is we don't want to get hurt. We don't want our friends, our coworkers to get hurt.